so for this one here, if I want to find out the average value of this function from 3 to 12 from this point to this point here, okay, what I want to do is find take that area, and I'm gonna make that area look about somewhere about here, a little bit lower than that. That looks about right. So that area, those two areas kind of cancel out. So I would say estimate the average value to be about 2. Okay, so again, we're going to take the formula, so the average value. I'm going to find the area underneath that curve from 3 to 12. Okay, and I'm going to divide it by the interval width from 3 to 12. The interval width is going to be 9. And that will give me, this essentially is going to give me the height. Okay, the area divided by width equals height. And that will give me the height of that rectangle, which represents the average value of that green line, square root x minus 3. So then, anti-differentiating this becomes x minus 3 to the power 3 over 2 over 3 over 2. Okay, I should really simplify that fraction. So this becomes, what is that going to be? 2 over 27, x minus 3 to 3 over 2, from 3 to 12. Evaluate that integral. So that will be, plug in 12 there. Square root is not, it's going to be 9. Square root is 3. Cubed in the numerator is 27. Okay, plug in the 3 into here. I get 0 minus 0. And this area is the area. I don't know what the area works out to be, but the average value is 2. And in fact, that is exactly what we can see here. Okay, I took that area underneath the curve. Okay, took this area under the curve here. Okay, it made an equivalent rectangle. I made an equivalent rectangle here and put that area inside, divided by the interval width of 9. Okay, which is that there, and that gives me the average. That gives me the height of the rectangle, which is the average height of that function. All right, for the next one here, well, that's what the graph looks like. Let's face it, we can just look at that and say from -1 to 1, it's symmetrical. About 0, the answer is 0. Okay. Well, we should practice doing our integrals though. So let's work out the average value here. Okay, so the average value. The interval width is 2 from -1 to 1, and we're going to use substitution to differentiate this. Okay, so u is equal to 1 minus x squared. Du will be -2x dx. Okay, so the -2 is going to go in the denominator there. So when I substitute here, I'm going to end up with 1/2. I'm going to have the -1/2 come on the outside here. That's going to be u du from x equals -1 to x equals +1. Okay, so I've done my I substituted for u. The du takes care of that x dx, and I have to make sure I have to have that extra divide by 2 to account for that coefficient there. Okay, so anti-differentiating this and working out the area underneath that curve, I get u squared from x equals -1 to +1. This ends up being, I'm going to substitute back in. What was that again? X minus 1, and it's going to be x minus 1, or 1 minus x squared from -1 to 1. When I plug that in, I get -1 over 4. Plugging in, I'm going to get 0 squared minus, plugging that in, I get 0 squared. The net area is 0. I can see that the area above and below cancel out. Okay, so then when I find the net area is 0, and the interval width is going to be 2. 0 divided by 2 is going to be still 0. Okay. This one here, again, we can do from 0 to 2. It's going to be this here. And I would guess that if I were kind of eyeballing it, maybe a little bit down around here, that this area looks equivalent to the area underneath the curve. Okay, so that straight horizontal line probably represents the average size, somewhere around 2. And again, what my double check is, I can see that the area outside the rectangle is equal to the area inside the white area inside the rectangle. So again, let's do substitution. Let u equal 2x squared plus 1. du is equal to 4x dx. Okay, that's going to take care of my integral. So I'm going to end up with du over square root u, and I'm going to integrate this from x equals 0 to x equals 2. My interval width is going to be 2. So there's my average value expression. Okay, so my average value is equal to, what's that going to be? Negative 1/2, so u to the positive 1/2 divided by the coefficient 1/2 from x equals 0 to x equals 2. Okay, those 1/2s cancel out, so I end up with 2x squared plus 1 to the power 1/2 from 0 to 2. So the average value of this function works out to be square root 5 minus square root of 1, or root 5 minus 1. Root 5 minus 1, I think, is about, I'm not too sure what the decimal value is. Okay, so that's going to work out to be the average value of that function from 0 to 2.